Okay, S1, question 9 from last summer. Right, a game is played with a token on a board with a grid painted on it. The grid is painted on the token, not the board. It's the other way around. The token starts at the point 0, 0, and now this is confusing just reading it, isn't it? Did you get that video? That was Paul complaining that I'm always filming. He says, I love the sound of my own voice. If I was doing that, I'd be doing this on the radio. Love the sound of my own voice and the view of my own face. Should we start this video again? Carry on, right, okay. Each step is either 1 unit in the positive x direction with probability 0.8 or 1 unit in the positive y direction from 0.2. The token stops when it reaches a point on the y coordinate of 1. It's given that the token stops at x1. Right, first thing is to work out what on earth is going on with this. So what's happening is, with a probability of 0.8, the token moves 1 square to the right. So if you get the 0.2 the first time, it stops. Moves 1 forward and stops. If it goes 0.8 and then 0.2, it moves 1 across and then forward and then stops. If it's 0.8, 0.8, 0.8 and then 0.2, it would be at 3x, wouldn't it? Yeah? So it would be at 3, 1. Does that make sense? So that is kind of 4 things that have happened, but the x would be 3 in that case, because it's moved 3 across and then 1 up to reach its stop point. So find the probability that x equals 10. In order for x equal 10, it's like, it is a geometric distribution, but it's not x that follows the geometric distribution. Because the geometric distribution, the variable is the number of trials of the thing. Well, the number of trials will always be 1 more than x, because you have the x numbers and then you have the 1 where it's moved forward. So the number of trials is 1 more than x. So x is the number of trials minus 1. Does that make sense? Now, for x to be equal to 10, that means what needs to happen is we need to have 10 0.8s and then a 0.2, so that it gets to the point where we're at x, where it's 10, 1. So that, probability of x being 10, is 10 skips to the right, followed by a skip up. If it doesn't do the final skip up, then x wouldn't be 10, x would be greater than 10 because it would go on. That gives us an answer of 0.0215 to 3 significant figures. Okay? So you see how we're relating it to the geometric distribution, but it's like the geometric distribution being 11. 10 failures and then 1 success, the y value. So the probability of x being less than 10, well, the easiest way of thinking about this is to do the reverse thing, isn't it? Because for it being less than 10, that's 1 minus the probability that x is greater than 10, greater than or equal to 10. Yeah. And in order for x to be greater than or equal to 10, that means we must have 10 of these failures before we eventually start moving up. If x is equal to 10, we have exactly 10 of those, and that probability means it could then carry on after that. So this is 1 minus 0.10, 0.8 to the 10, which is, sorry, I'm just going to write the answer there, which is 893. Now what I noticed when we were doing this is that lots of you did this one as being 1 minus this one. Yeah, can you recognise that? Quite a few people did that. And you see how they're different things. Probability of x being 10 means it's exactly 10, and then we've stopped. So in order for it to be exactly 10, we then have to have that 0.2 where the y increases by 1. Probability of it being less than 10 is having our 10 moves across and then not stopping. You know, we either then have it moving up or it carrying on moving across. Part 2. Find the expected number of steps taken by the token. Well, like I said, this was a geometric distribution thing, wasn't it? And actually, the number of steps taken by the token is the geometric thing. That is one more than x, isn't it? Because x is the number of steps across before the final one up. So this is just, this number of steps fits the geometric distribution perfectly. So the expected number of steps, because the number of steps is a series of failures followed by a success as it moves up one. So that is, how do we find the mean of a geometric distribution? It's 1 over the probability of a success, which is that final y step, which gives us 5 as the expected number of steps. Now I think we've already explained the last bit, hence write down the value of e of x. Well, what happens in this is you have a certain number of steps and then you move up one. The number of steps is what happens all the way along and then you move up one. X is how many along you've got before you move up that one. So it's 1 less than the number of steps. And 5, when you take 1 away from it, is equal to 4. And there you go. That is the expected value of x. No other thing that you need to put for that. That's it done. Great. Maths.